In this lecture, we will learn about what design patterns are and who the Gang of Four are. An iconic book, possibly the most important book in all of computer science, called Design Patterns: Elements of Reusable Object-Oriented Software, was published over 20 years ago on October 21st, 1994. There were four authors, all of whom were computer scientists, that have been nicknamed the Gang of Four. You may also see Gang of Four abbreviated as GOF. The book, Design Patterns: Elements of Reusable Object-Oriented Software, contains 23 design patterns that revolutionized computer science. Put simply, a design pattern is a general, reusable solution to a commonly occurring problem in software engineering. There are three main types of design patterns: creational, structural, and behavioral. Creational design patterns are used to create objects. Structural design patterns are used to provide relationships between objects. Behavioral design patterns help to define how objects interact. Creational design patterns are used to create objects. It is important to use the pattern that best fits the needs of the situation. There are two main ideas that come into play with creational design patterns. One is encapsulation, specifically encapsulating the knowledge about which classes the system uses. The other is hiding how instances of these classes are created and combined. Creational design patterns strive to separate a system for creating, composing, and representing objects. The creational design patterns that we will learn about in the following lectures are abstract factory, builder, factory method, prototype, and singleton. The abstract factory pattern lets us create objects without specifying their type. The builder pattern facilitates the creation of complex objects. The factory method pattern creates objects without specifying the exact classes to create. The prototype pattern creates a new object from an object that already exists. The singleton pattern ensures that only one instance of an object is created and exists in the app at any one time. Structural design patterns define the relationships between objects. They help ensure that even if one part changes, the entire structure of the code doesn't need to change. The patterns focus on inheritance as a primary component, specifically how classes inherit from one another and how they are composed from other classes. Structural patterns allow us to compose objects in different ways to create new functionality. The structural design patterns we will learn about in the following lectures are adapter, bridge, composite, decorator, facade, flyweight, and proxy. The adapter pattern allows for two classes that are not compatible to work together by using an interface with one of the existing classes. The bridge pattern decouples two classes so that they can vary independently. The composite design pattern takes a group of objects and combines them into a single object. The decorator pattern lets an object's behavior get extended at runtime. The facade design pattern provides a simple interface, allowing us to work with a more complex object that the interface works with. The flyweight pattern reduces the overhead of creating complex object models. The proxy pattern provides a placeholder interface aimed at controlling access, reducing cost, or lessening complexity. Behavioral design patterns help to define how objects interact. These patterns increase the flexibility in the communication between objects. Behavioral patterns focus on assigning responsibilities between objects. They focus on the way that objects are interconnected. The behavioral design patterns that we will learn about in the following lectures are chain of responsibility, command, interpreter, iterator, mediator, memento, observer, state, strategy, template method, and visitor. The chain of responsibility pattern delegates commands to a chain of objects that processes those commands. The command pattern creates objects that encapsulate actions and parameters. The interpreter pattern interprets user input and uses an abstract syntax tree. The iterator pattern lets us access the elements of an object in sequence without having to expose the underlying representation of the object. The mediator pattern provides loose coupling between classes by ensuring that only the mediator class has detailed knowledge of their methods. The memento pattern lets us restore an object to its previous state. The observer pattern allows us to let observer objects subscribe to events that are sent out by publishers. The state pattern lets an object alter its own behavior when its internal state changes. The strategy pattern lets the program select which algorithm to use from several choices at runtime. The template method pattern lays out the skeleton of an algorithm using an abstract class, allowing its subclasses to define its behavior. The visitor pattern moves the hierarchy of methods into one object, separating an algorithm from object structure. In the next lecture, we will learn more about creational design patterns.